This lesson is on simplifying exponential expressions. And let's remind ourselves of some of the basic facts we're working with. If I have x to the third times x to the fourth, what does that mean? That means x times x times x times x times x times x times x, which means x to the seventh. So of course, x to the m times x to the n, right, is x to the m plus n, right? 3 plus 4, x to the third times x to the fourth is x to the 3 plus 4, which is x to the 7. That's our first rule, is the bases are the same, we add the exponents. Now, if I have x to the fifth to the second power, what does that mean? That means you write what's in the parentheses twice, multiply by itself. So that's x to the fifth times x to the fifth. What does that mean? That means x times x, which of course is the same thing as x to the 10th. So you can see what happened there is we multiplied the exponents. X to the fifth to the second power was x to the 5 times 2 to give me x to the 10th. And then our general rule there is if I have x to the m raised to the n power, that is x to the m times n. That's another rule for us to keep in mind. Then, of course, we have this sort of a situation. If I have x to the sixth over x to the second, what does that mean? X to the sixth means x to the second means x. And then we divide out. X over x is 1 over 1. X over x is 1 over 1. What's left upstairs? 1 times x times x times x times x, x to the fourth over 1 times 1 is 1, which is x, which indicates to me that x to the sixth over x to the second is the same thing as x to the sixth minus 2, which is x to the fourth. So indeed, x to the m over x to the n is x to the n minus n. But if I flip that, if I have x to the 2 over x to the sixth, using that rule, that would be x to the 2 minus 6, which is x to the negative 4. So what does x to the negative 4 mean? What does the negative exponent mean? Well, again, x to the second over x to the sixth means x times x over x. And what divides out? X over x, same as 1 over 1. X over x, same as 1 over 1. What's left upstairs? 1 over 1 times 1, x, 1 over x to the fourth. So that reminds us of our negative exponent property. X to the negative fourth is 1 over x to the fourth. That's what that means. So those are our basic rules, and we're going to use those to evaluate some concepts. So relatively simple ones. If I have x to the third to the fourth power, in your mind, you see x to the third times x to the third times x to the third times x to the third. Write all that out, we see x to the 12th. But using our rule, that's x to the 3 times 4, which is x to the 12th. If I had a number, right, if I have 5 to the second to the fourth power, again, same kind of an idea. 5 to the second, 5 to the second, 5 to the second, 5 to the second. How many 5s do we have? 5 to the 8th, or 5 to the 2 times 4, which is 5 to the 8th, whatever that very, very large number is. But the same thing kind of works with negative exponents. I mean, if I have x to the negative 3 to the second power, what's going to happen there? So you'll notice we multiplied the exponents here. The same thing is going to happen here. It's going to be x to the negative 3 times 2, which is x to the negative 6. And we don't typically like negative exponents in our answer. So we're going to rewrite this. X to the negative 6 means 1 over x to the 6th. If you're not really convinced of that, you know 1 equals x to the 0, right? So 1 over x to the 6th is x to the 0 over x to the 6th, which is x to the 0 minus 6. which is x to the negative 6, just to kind of convince you one more time that that's how that has to behave. But if I have z to the negative 2 all raised to the negative 5th power, this is a little difficult for us to visualize, but the rule extends. When you raise a power to a power, you multiply the exponents. So it'll be z to the negative 2 times negative 5, which is z to the 10th power. That's how that's going to work. So let's take a look at a couple more of these as we are raising powers to powers with and without negative exponents. These are the kind of things you want to think about. If I have, for example, 3x squared to the 4th power, what does this mean? It means 3x squared, 3x squared, 3x squared, 3x squared. So let's not lose sight of that. 3x squared times 3x squared times 3x squared times 3x squared. But so maybe you could simplify it from there, right? 3 times 3 is 9, times 3 is 27, times 3 is 81. X squared, x squared, x squared, x squared, xx, 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 that's x to the 8th. Fine, we can see it that way. But let's go ahead and use our rules. The exponent on 3 is 1. So it's 3 to the 1st to the 4th power. So that's 3 to the 1 times 4 and x to the 2 times 4. Raising powers to powers, we multiply the exponents. So that's 3 to the 4th times x to the 8th, which is 81 x to the 8th, which is the same thing that we had gotten above. What if I do a fraction? What if I do 3/5 to the 2nd power? What's happening here? Again, I believe make the exponents 1. So 3 to the 1 times 2 over 5 to the 1 times 2. 3 to the 1 times 2 over 5 to the 1 times 2. That gives me 3 to the 2nd over 5 to the 2nd. 3 to the 2nd means 3 times 3. 5 to the 2nd means 5 times 5, which of course is 9 over 25. Does it get more interesting? Sure. What if I have something like this? 2x squared y over z cubed, all raised to the 4th power. So how do we handle something like this? I believe in giving the exponents of 1. 2 has an exponent of 1, y has an exponent of 1, the others have exponents. When you raise a power to a power, you multiply the exponents, as we saw above. 2 to the 1 times 4, 2 to the 4, x to the 2 times 4, the x to the 8th, y to the 1 times 4. That's y to the 4th, z to the 3 times 4. That's z to the 12th. What does that give me? 2, 4, 8, 16. 2 to the 4th is 16. 2 times 2 times 2 times 2. X to the 8th, y to the 4th, over z to the 12th is where that goes. But we can also play games with negative exponents. So what happens with those? What if I have something like this? What if I have 3 to the negative 2nd over x, all raised to the negative 3 power? Well, the rules I like, again, give each exponent of 1 if something is missing an exponent, so x doesn't have 1. When you raise a power to a power, you multiply the exponents. So 3 to the negative 2 times negative 3 over x to the 1 times negative 3. Well, negative 2, hopefully you can read that. Negative 2 times negative 3, that's 3 to the 6th. That's a big number. X to the 1 times negative 3 is x to the negative 3. Now, what does that mean, right? I mean, so we have this very large number. We have 3 to the 6th, which I'll quickly check my calculator to see what that is. 3 to the 6th power is 729. So on top, I have 729. On the bottom, x to the negative 3 means 1 over x to the 3rd. So let's not forget that this means 729 divided by 1 over x to the third. If we're dividing fractions, 729 over 1 times x to the third over 1, and I get 729 x to the third. But the other way we could have thought of that, when I get to this point, 3 to the 6th over x to the negative 3. If you have a negative exponent, you can move it either from downstairs up or upstairs down. What's left here is 1, of course, when I move it. So moving it upstairs, then I get 3 to the 6th times x to the third. Once it moves, the exponent is no longer negative, all over 1, which again gives me 729 x to the third over 1, which is 729 x to the third. Let's do one more with some bigger numbers this time. Let's take a look at the following. What if I have x to the negative 3, y to the negative 4, z to the second, all raised to the 5th power? What's going to happen here? When we raise powers to powers, we multiply exponents. So x to the negative 3 times 5, that would be x to the negative 15. Y to the negative 4 times 5, that's y to the negative 20. Z to the 2 times 5, that is z to the 10th. Now, what do these things mean? X to the negative 15 means 1 over x to the 15th. Y to the negative 20 means 1 over y to the 20th. What does z to the 10th mean? It means z to the 10th over 1. So if I do this, 1 times 1 times z to the 10th, z to the 10th upstairs, x to the 15th, y to the 20th downstairs, is what we get there. So it's just always important for us to think about the basic rules, but also think about what these things represent. What do they mean? All right. What other sorts of things can we look at here? Let's take a look at something like this. Three x to the 0, y to the negative 4 to the negative 2. And let's remember, what is x to the 0? X to the 0 equals 1 as long as x itself isn't 0, as long as x is not 0. But our rules here still work the same way. Give everything an exponent of 1. When you raise a power to a power, multiply the exponents. 3 to the 1 times negative 2, 1 times negative 2 is negative 2. X to the 0 times negative 2, that's x to the 0. Y to the negative 4 times negative 2, that's y to the 8. And then what does that mean? What does that represent? 3 to the negative 2 means 1 over 3 squared. X to the 0 is just 1, if you want 1 over 1. Y to the 8th is y to the 8th, y to the 8th over 1. Put all that together, what's left upstairs? 1 times y to the 8th. What's downstairs? 3 times 3, 9 times 1 over 9 is where that goes. How about something like this? How about 3/5 to the negative 2? Again, same kind of idea. Put an exponent of 1, put an exponent of 1 here. Raise the power to the power. What's going to happen? 3 to the 1 times negative 2. 3 to the negative 2, 5 to the 1 times negative 2, 5 to the negative 2. And this time, let's play the movement game. So 3 to the negative 2 moves downstairs, the exponent becomes positive. 5 to the negative 2 moves upstairs, exponent becomes positive. So where does that leave me? 5 to the negative 2 goes upstairs, becomes 5 to the second. 3 to the negative 2 moves downstairs, becomes 3 to the second. What do I have? I have 25 over 9. Now, we can put all these things together in the event I have something like this. 2 to the negative 3, x to the negative 4, y to the 6th, x squared y to the negative 2. How am I going to handle this sort of thing? Well, you can think about what it means. We can do the long way, or we can recognize whenever you have a negative exponent, it moves, and the exponent changes. So 2 to the negative 3 moves downstairs and becomes 2 to the third. X to the negative 4 moves downstairs and becomes x to the fourth. Y to the 6 stays upstairs. X to the second stays downstairs. But y to the negative 2, negative exponent, moves upstairs and becomes y to the second. Now what is this? Y to the 6 times y to the second. Y, a total of y to the 8th. Downstairs 2 cubed 8. X to the 4th times x to the second is x to the x, 8, x to the 6th. All right, let's take a look at one last problem that kind of deals with multiplication and raising powers. So let's try something like this. 3x squared over 2 y to the negative 1, all raised to the negative 2 times nine y to the fourth x, all raised to the negative 1. So we're going to multiply these two things together and see what we get. Step 1, everybody gets an exponent. Boom, 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 boom. When you raise a power to a power, we multiply the exponents. So 3 to the 1 times negative 2 is 3 to the negative 2. X to the 2 times negative 2 is x to the negative 4. 2 to the 1 times negative 2 is 2 to the negative 2. Y to the negative 1 times negative 2 is y to the positive 2. Do a quick mental check to make sure I haven't made an error. 1 times negative 2, negative 2, 2 times negative 2, negative 4, 1 times negative 2, negative 2, negative 1 times negative 2, positive 2 times x to the 1 times negative 1, that's x to the negative 1. 9 to the 1 times negative 1, that's 9 to the negative 1. Y to the 4 times negative 1, that's y to the negative 4. Okay. What moves now? 3 to the negative 2 moves downstairs, becomes 3 to the second. We see that. X to the negative 4 moves downstairs, becomes x to the fourth. 2 to the negative 2 moves upstairs, becomes 2 to the second. Y to the second stays downstairs as y to the second. On the right side, everything moves. X to the negative 1 moves downstairs, becomes x to the 1. 9 to the negative 1 moves upstairs, becomes 9 to the 1. Y to the negative 4 moves upstairs, becomes y to the fourth. So now we are multiplying all of this. So I can make it a single fraction that we're going to try to reduce. 2 squared is 4 times 9 times y to the fourth. 3 squared is 9. That'll divide out nicely. What's the status with my x's? X to the fourth times x to the first would give me x to the fifth. And then there's a y squared down there as well. What divides out? 9 divided by 9 divides out. That's kind of nice. Now what do we have? I have 4y to the fourth. 4y to the fourth, because I have y's on the top and the bottom. I got to think about those. Then I have x to the fifth. Nothing divides out there. And then I have y squared. So you'll notice that these y's divide out. Y over y becomes 1 over 1. Y over y becomes 1 over 1. And what is my result? 4y squared on top. What's left on the bottom? X to the fifth times 1, or x to the fifth.